Good morning, students. Today we are going to discuss torque acting on an electric dipole placed in an uniform electric field. As you know, electric dipole is a system of two charges equal and opposite separated by small distance. And also you know uniform electric field. It's a region where electric field intensity is constant. In the earlier class, you studied how to represent uniform electric field region pictorially. Using electric field lines, we can represent uniform electric field region, isn't it? How? By drawing straight, parallel, equidistant lines. So, let us draw a uniform electric field region using electric field lines. So, this is how we represent a uniform electric field region. What I am drawing? I am drawing straight lines, parallel, equidistant. Now, this region is a uniform electric field region, meaning at every point in this region, a unit positive charge experience equal force in magnitude as well as direction. So this is a uniform electric field region. Now I am going to keep a dipole. You know, dipole consists of a minus q charge and a plus q charge, right? Minus q charge plus q charge. You know, the separation is usually represented with the symbol 2L. So this is an electric dipole consists of minus q charge and a plus q charge. Now this figure shows an electric dipole placed in a uniform electric field region of intensity E. As you know, electric field region means it's a region where the charge placed experience force. Since this is a plus q charge placed in a uniform electric field region of strength E, this plus q charge will experience force. How much force? You know, force on a charge, force on plus q charge placed at B. This is point B. F equal to formula EQ. You know, E equal to F by Q. E equal to F by Q എന്ന് പഠിച്ചിട്ടില്ലേ? ഇയുടെ ഡെഫിനേഷൻ ഇങ്ങനെയല്ലേ? സോ എഫ് ഈക്വൽ ടു ഇങ്ങനെ ക്രോസ് മൾട്ടിപ്ലൈ ചെയ്ത് കിട്ടിയതാണ് ഇ ക്യു. എല്ലാ ഡെഫിനേഷൻ ഉപയോഗിച്ചിട്ടും ഈ റിലേഷൻ നമുക്ക് മനസ്സിലാക്കാം. E is force acting on 1 coulomb. So Q charge experience how much force? EQ force. Now what is the direction of this force? Direction of this force will be along the direction of E. So E യുടെ ഡയറക്ഷനിലാണ് പ്ലസ് ക്യൂവിൻ്റെ മുകളിലുള്ള ഫോഴ്സ്. This is the direction of EQ force. Similarly, minus Q also experience force. Force on minus Q placed at A. How much will be the force? E into minus Q. So it will be minus EQ. What is this negative sign shows? In a vector, if a negative sign comes, it shows left side quantity and the right side quantity as opposite direction. So here this minus sign shows minus Q will experience force in the opposite direction of E. ഇയുടെ ഓപ്പോസിറ്റ് ഡയറക്ഷനിലാണ് ഈ ഫോഴ്സ്, ഇയുടെ സെയിം ഡയറക്ഷനിലാണ് ഈ ഫോഴ്സ്. കാരണം ഇത് പ്ലസ് ക്യൂ ആയതുകൊണ്ട് ഇത് മൈനസ് ക്യൂ ആയതുകൊണ്ട്. ഹിയർ യു സീ two equal force opposite in direction acting in different line. This is the direction of one force, this is the direction of another force. Two are equal magnitude wise, opposite direction, not in same line, they are in different line. You see some distance between these two direction of force. So whenever two force acting on a body equal in magnitude, opposite in direction but acting in different line, they constitute a couple. കഴിഞ്ഞ വർഷം പഠിച്ചിട്ടുണ്ടാവും. Couple, pair of force equal in magnitude, opposite in direction, acting in different line. Then also you studied couple can create torque. Couple can create torque on a body. ഞാൻ സിമ്പിൾ എക്സാമ്പിൾ പറയാം. When we open a top of a bottle, ഒരു ബോട്ടിലിൻ്റെ ടോപ്പ് നമ്മൾ തുറക്കുമ്പോൾ 2 ഫിംഗർ കൊണ്ട് തിരിക്കുകയല്ലേ ചെയ്യുന്നത്. ആ 2 ഫിംഗറും ചെയ്യുന്ന കാര്യം നമ്മൾ കഴിഞ്ഞ വർഷമൊക്കെ എക്സാമ്പിളിൽ പറഞ്ഞിട്ടുണ്ടാവും. 1 finger is pulled forward, another finger is pulled backward. So 2 equal and opposite. They create a couple. Couple automatically result torque. Here, so there will be torque. Now, what is torque? Formula. Torque on the dipole. Who create this torque? Torque on the dipole. Who create this torque? This couple. Who is that couple? This pair of force. Torque on the dipole. Torque due to couple formula എന്താണ് അറിയാം? One of the force into perpendicular distance between line of action of forces. One of the force. These two forces are equal. So you take one of the force, EQ. One of the force is EQ. Now we require distance between, perpendicular distance. For that I drop a perpendicular in this figure. Drop a perpendicular in this figure. Mark it as C. Here this distance BC is perpendicular distance between these two directions. This is the direction of one force. This is the direction of another force. So this distance will be the perpendicular distance. Put x for this BC. So here P EQ into x. Now I require this x. Let us put this angle as theta. What is this angle? This is the direction of dipole moment. Negative charge to positive charge. This is the direction of dipole moment. This is the direction of electric field. So here theta is angle between dipole moment and electric field. So from the figure you consider triangle ACB. You see ACB? From triangle ACB, what is sin theta? Sin theta is opposite by hypotenuse. Opposite is our x. Hypotenuse is 12. So x equal to x equal to 12 sin theta. You put x equal to 12 sin theta. So our equation for torque become EQ into 12 sin theta. Torque in the symbol torque. Now you know Q into 12 is Q into 12 you studied as P. So P E sin theta, where P is equal to Q into 12. Ready? So this is the equation for torque acting on a dipole placed in a uniform electric field region. Tau equal to P E sin theta. In vector form, torque is a vector. So we have to write the vector form. P cross E. What is the direction of this torque? Torque act perpendicular to P cross E. Perpendicular to P cross E is P ingotake, E ingotake. P cross E in the direction, screw rule use cheyyanam. Screw rule engane use cheya? Ivide ninnu ividathekku screw thirikka. And ingotake thirikkunna P in the direction idanu P in the direction. P idanu E. Appo P cross E ingotake varuva? P cross E thirikkumbo inward. So the direction of torque is inward in this case. Now in a special case when theta equal to 0 or 180 degree, torque become minimum. എന്തുകൊണ്ടാണ് മിനിമം എന്ന് മനസ്സിലായ? P sin 0 P sin 180 0. ടോർക്ക് മിനിമം ആവാനുള്ള കണ്ടീഷൻ കിട്ടി. ഇനി എപ്പോഴാണ് ടോർക്ക് മാക്സിമം ആവുക? Torque maximum when theta equal to 90 degree, torque become maximum. PE sin 90 value at varum sin 91 alla appo varuva PE. This is the maximum value of torque. This is the minimum value of torque which is 0. ഈ മിനിമം വാല്യൂ ടോർക്ക് ആവുന്ന കേസുകളാണ് എന്ത് വിളിക്കുമെന്ന് വെച്ചാൽ ഇക്വിലിബ്രിയം കണ്ടീഷൻ. ടോർക്ക് സീറോ ആവുന്നതിന് ഇക്വിലിബ്രിയം, റൊട്ടേഷണൽ ഇക്വിലിബ്രിയം കഴിഞ്ഞ വർഷം പഠിച്ചിട്ടുണ്ട്. സെക്കൻഡ് കണ്ടീഷൻ ഓഫ് ഇക്വിലിബ്രിയം എന്ന് പറഞ്ഞിട്ട് റൊട്ടേഷൻ മോഷനിൽ ഒരു ലോ തന്നെ പഠിച്ചിട്ടുണ്ട്. അതിൽ പറയുന്നുണ്ട് ടോർക്ക് സീറോ ആവുന്ന സ്റ്റേറ്റിനാ ഇക്വിലിബ്രിയം എന്ന് പറയും. സോ ദിസ് ഇസ് അബൌട്ട് the derivation. Torque acting on an electric dipole placed in a uniform electric field region. So you have to take down this derivation. First you write the heading like this, then you draw this figure. You draw this figure. Then after drawing you have to describe this figure like this. First you have to write like this. Consider an electric dipole which consists of minus q charge placed at A and plus q charge placed at B in a uniform electric field region of strength E as shown in the figure. Let 12 be the length of the dipole and theta be the angle between the direction of dipole moment P and electric field intensity E. As in the figure, as shown in the figure. So figure I, description I. Then you draw all this force direction. Then you write force on the plus q charge, force on minus q charge. If there is a sentence, the direction of force is along the direction of E. The direction of force on plus q is along the direction of E. The direction of minus q charge is direction of force on minus q charge is opposite to the direction of E. Opposite. In a sentence, since these two forces are equal in magnitude, opposite in direction, acting in different line, create torque on the dipole. Torque on the dipole formula. Copy. Okay. So for today this much enough. We will meet again next class. Thank you.